Cycle 3, Lesson 5, Part 1, we're going to start looking at how we can use some of the techniques we've learned up till now to solve polynomial equations algebraically. So we've learned about factored form, how to put a polynomial in factored form, and we can identify zeros and x-intercepts of the corresponding graph. And of course, if we let a polynomial function, if we let y equal 0, then we can solve the related equation p at x equals 0. If a polynomial equation is factorable, then the roots can be determined algebraically by solving the linear or the quadratic factors that we get. Okay, so mostly what I've got for this lesson is a few examples of different kinds of things that we might see. So the first one, what we always want to do, whether we're dealing with cubic or quartic or whatever the degree is we always look for a common factor to start with. That should be whenever we're solving things, the first thing we should do is always begin by looking for a common factor. In this case, I can see that there's an x that I can take out of each of these terms. And when I do that, the whole problem becomes a lot easier, because what's there in brackets is just a quadratic, and that's factorable just by finding two things that multiply to give -2 and add to give -1. And that, with a little bit of thought, would be -2 and +1. From that, I can then pull my zeros out of the factors. So everyone remembers to do, okay, well, this is x equals 2 and this is x equals -1. But not everyone remembers that this is also a factor. Even though it's not in brackets, that's a factor. Whenever you have an x out front, not in brackets, that's going to give you a 0 of 0, a solution of 0. So those are the three solutions to this equation. Okay, sometimes we're going to see ones that we can group. So what we want to do, if we see one that's got usually for us anyway, it's going to be 4 terms. And so if you want to think about it as a group, so just look at the first 2 terms, look at the second 2 terms, so the first and second term, the third and fourth term, and just imagine pulling out a common factor from the first group. So from 3x cubed plus x squared, if we were to get what the GCF, the greatest common factor, is from that, it would be x squared. And then we'd be left with 3x plus 1. If we were to get the greatest common factor out of the second group, the minus 12x minus 4, I would be able to take a minus 4 out of there, and when I common factor it, I would be left with 3x plus 1. If I do that, and I get the same binomial in each set of brackets, then that means that factoring by grouping is going to work, because then I can imagine that I'm taking that 3x plus 1 out as a common factor itself. So in other words, imagine that this is a whole unit and this is another whole unit, and I'm going to take the 3x plus 1 out of both the red unit and the green unit, so it's become my common factor, and what I'm left with now is x squared minus 4. And then I can carry on with factoring. 3x plus 1 is factored as far as it can go, but x squared minus 4 is a difference of squares. It can be broken down farther. And then, again, x equals 2, x equals -2, and as far as this one goes, you want the x value that's going to make the bracket equal 0. So either you can mentally play with that in your head, but if you have trouble just coming up with that, then you can always set the bracket equal to 0 and then solve the equation. And you'd get -1/3. So there's 3 solutions to this one as well. One final word about factoring by grouping. Just because there's 4 terms, like there were in this original question, doesn't mean it'll always work with factoring by grouping. The only way to really know is to look at it and either start taking out common factors the way I did in the second line here, or mentally do it, one way, either on paper or in your head. And if it doesn't work out that you get the same thing in both brackets like I did, then you'll know that factoring by grouping is not the answer for the way to approach this, and you have to go to a different approach. And what that other different approach is going to be what we pretty much did in the last couple lessons, where we find a factor and then divide. So if I look at this group here, maybe I could do it by factoring by grouping. If I was to do that, then I'd have to take, the most I could take out of the first 2 terms would be x squared. And then out of the second 2 terms, these ones here, there's really nothing I can even take out. So factoring by grouping, pretty quickly it becomes obvious that that's not going to work in this case. So what do? Well, we look for a factor. Remember, we can look for factors of the constant term 2, and so all we need to really worry about is plus or minus 1 and plus or minus 2, because our factors have to go into the constant term. So again, I might just try thinking of this whole thing as if it's a function. Imagine that's an f at x. So then if I find out f at 1, if I look at f at 1, then I'm going to have 1 plus 6 plus 9 plus 2, which is going to equal 18. Does not equal 0, not a factor, right? If I try negative 1, then I get negative 1 plus 6 minus 9 plus 2. Then I've got myself negative 2, I think. Whatever it is, it's not 0, not a factor. So I just keep doing this. I don't have to write them all down, but I keep going until I find something that works. Let's try positive 2. 8 plus 24 plus 18 plus 2. Well, that's not looking good. I think that's 52. Well, the only thing left, if there's going to be a factor, the only one left that it might be is negative 2. If I put that in into the function, that does equal 0. So that means that x plus 2 is a factor, and I can then divide by that factor. I can use synthetic division in this case because it sets up with no value in front of the x in the factors for division, so I can just go negative 2 and then grab all the coefficients from up above. So it'd be 1x cubed plus 6x squared plus 9x plus 2. So there's my coefficients. Quickly go through the synthetic division. I get negative 2. So negative 2 times 1 is negative 2. Add 4, negative 8, add 1, negative 2, add 0. Remember, this is the remainder, and the rest of it's just coefficients for what's left. So far, I have my first factor, which was x plus 2, over here. And then I have 1x squared plus 4x plus 1 as the rest of it equal to 0. So I've just rewritten this original equation in a partially factored form. So what we've seen is that we would then take this and try to go further with what's in the brackets. So I would look for 2 things that multiply to give 1 and add to give 4, and can't think of anything. We could try using the quadratic formula, but then it's not really a factor. We could go to Desmos as a quick way to check. X squared plus 4x plus 1. And it does have roots, but those are decimals. So I'd have to either use Desmos to see what those roots are, or I'd have to use the quadratic formula. Either way, factoring is not going to work. So if I was required, if this was a no Desmos type situation, then of course, here's a quick reminder of how the quadratic formula works. X is equal to negative b, so remember here's a, b, c in our original quadratic. So negative b would be negative 4 plus or minus the square root of b squared, so 4 squared, minus 4 times a times c, all over 2a, and again a is 1. So I get negative 4 plus or minus the square root of 12, that works out to, over 2, and I get, again, just put it in the calculator, negative 0.27, and I also get negative 3.73, which is what we see on Desmos. But again, if we can't go to Desmos, we still have the quadratic formula. So the solutions are this one, and then the x also, and x equals negative 2 from when we used the factor theorem. Sometimes a polynomial equation might have real roots combined with non-real roots. So let's consider the solution of the polynomial equation x minus 3 times x squared plus 1 equals 0. It's already been factored for us, right? We can see that we get a root of x equals 3 from the first bracket, but there's no way to solve this bracket here. If I try the trick of setting it equal to 0 and then isolating x, what I get is x squared equals negative 1. If I take the square root of each side, then I would be trying to take the square root of negative 1, and that's not a real root. It's not a, and by a real root, we mean it's not a real number. There is no real numbers that you can take the square root of a negative number. So this is our only solution here. This last one, where it says solve this equation and round the roots to one decimal place, that's a bit of a tip-off that we're not going to be able to solve it all by factoring because there wouldn't be any decimal places. So we're being given a bit of a heads up here that something's going on. First thing though I'd do is I'd put it into standard form. So I would bring that negative 1 over to the left, make it a positive 1. And if I were to go through and assume that, don't assume that I can't factor it. So if I assume that I could factor it, my only possibilities are plus or minus 1, since my constant term is 1. If I try to find the f at 1 on the related function, then I'm going to have 1 minus 3 plus 1. So that's not a factor. If I try negative 1, I'm going to have negative 1 plus 3 plus 1. Also not a factor, because it's not equal to 0. So can't use the quadratic formula because we've got a cubic here. There is such a thing as a cubic formula, but you don't want to go there. I mean, if you're interested in seeing a crazy difficult formula, a crazy big formula, go ahead and Google that. But we're not going to go down that road. So since it's not a quadratic, really all that's left is Desmos. We have to use Desmos in this case if we are going to solve it. think that was the equation. Yes, it was. And we've got 3 zeros. As we can see, negative 1.88, approximately 0.35, and 1.53. And there you have it, a selection of ways to solve polynomials, mostly algebra.